students, today we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry mole concept. Come on, let us discuss few more important questions from this session. Here the first question, calculate the number of neutrons present in 12 into 10 to the power of 25 atoms of oxygen 8, oxygen 17. They have given that Avogadro number also, right? Now this is actually very simple. See, as we observe that atomic number and mass number and element, how do we identify? Here this is X is an element, here Z is an atomic number, A is a mass number, right? So here this is an element, right? Now this is mass number. So mass number means protons plus neutrons, so that is mass number. And this is atomic number. So atomic number means protons only, so protons or electrons. Okay, now next one, number of neutrons, how to identify? So number of neutrons equal to mass number minus atomic number, that is A minus Z. So these two things you will get that neutrons, right? Now this is very simple, but in the question, number of neutrons present in 12 into 10 to the power of 25 atoms of oxygen 8, oxygen 17. Come on, this question, it's really interesting and important also. Come on, let us check here. So here atomic number of oxygen in this question. Okay, so atomic number, it is a constant. Okay, in this question also the same, right? Atomic number of oxygen here, what they mentioned, oxygen 8, oxygen 17, right? So here atomic number, what it is? 8. So that means what it is? Protons. And mass number, what it is? Mass number. So mass number of oxygen, that is 17. Number of neutrons here, number of neutrons here, mass number minus atomic number, so you will get number of neutrons. So mass number is actually what it is? A, and atomic number it is Z. So Z minus what it is? A minus Z, right? A minus Z, you will get what it is? Here A minus Z only, no? So that is what I just bring it. So you will get what it is? 17 minus 8, you will get 9 neutrons. Right, got it. Now we have to identify number of neutrons present in 12 into 10 to the power of 25 atoms of oxygen. So number of neutrons present in, this is not nitrogen, this is neutrons. Number of neutrons present in 12 into 10 to the power of 25 atoms of oxygen, that is 8, oxygen 17, right? Okay, now how to identify? This is very simple. For that, what formula can we use? Number of atoms, what they have given the data, so that is number of atoms into neutrons per atom, neutrons per atom. Right, now I just explained this point. So number of atoms means this is number of atoms. See, that's what they mentioned, 12 into 10 to the power of 25 atoms of oxygen. So that is number of atoms into neutrons per atom, that is number of neutrons. We just now found this. So that is what. So how do we calculate this? 12 into 10 to the power of 25 atoms into neutrons per atom, it is 9. So you will get what it is? 108, right? So you will get what it is? 108 into 10 to the power of 25 atoms. So number of atoms present in so and so. So you will get this one. Okay, now Avogadro number. So here in this point, neutrons present in all over. So in that scientific notation, how do we write it? So this is actually 1.08 into 10 to the power of 27 atoms. So how many neutrons? Number of neutrons present in so and so. So number of neutrons present in 12 into 10 to the power of 25. So you will get 1.08 into 10 to the power of 27 atoms. Okay, now we have to express in Avogadro number also. So Avogadro number, how do we identify? Na they have given. So Na, that is equal to what it is? 1 minute. So here Na, that is equal to what it is? 6.023 into 10 to the power of 23. But here they mentioned only 6 into 10 to the power of 23. So number of moles. So number of moles, what it is? In that number of moles, neutrons present in that atom. So here what it is? Number of atoms present divided by Avogadro number, that is 12 into 10 to the power of 25 divided by Avogadro number 6 into 10 to the power of 23. In the question it has mentioned that one. So here you will get what it is? 2 into 10 to the power of what it is? 2. So 2 into 10 to the power of 2, no? So you will get what it is? 200 moles of atom, right? So you will get what it is? 200. So 2 into 10 to the power of 2, it is 200 moles of atom. 200 moles of atom. So total number of neutrons. So total number of neutrons. So total number of neutrons. Total number of neutrons, how much? Here 200 into 9 into Avogadro number. Avogadro number Na we can mention. So we can write here when you are calculating, this is 18. So 1800 Na. So this is the answer. I hope you got the clarity. So total number of neutrons. First per atoms of neutrons we found. After that we found 12 into 10 to the power of 25 atoms. In that how many neutrons we found. And finally number of neutrons in the total Avogadro number including. So that is what number of moles of neutrons present in that atom. Number of moles of neutrons present in that atom. So that is what you got this, right? So that is number of moles of neutrons. So the 2 into 10 to the power of 2. Okay, so you're getting 200 moles of atoms. Then finally you're getting what it is. So that is actually 1800. So 1800 is the answer. 1800 of what? Avogadro number, right? Hope you got the clarity. Now come on, let's go to the next question. The answer it is 1800. Got it? Okay, come on. Let's go to the next question. Mass of one atom is 3.32 into 10 to the power of minus 23 gram. Then calculate number of nucleons, that is neutrons and protons, that is nucleons. Neutrons and protons, it is nothing, mass number only, right? Present in two atoms of the element. See, we are talking about atoms only. Even last question also, neutrons, number of neutrons present in that so and so atoms. So atoms only we are considering in this also. Okay, come on, let us discuss. So generally here nucleons, they mention, no, nucleons, it is nothing. Neutrons plus protons. So neutrons, protons, it is what it is? Mass number. So mass number, how do we identify? A, right? I hope you got that idea. Okay, come on. So here I just mentioned nucleons, okay? Nucleons equal to protons plus neutrons. That is also known as mass number, right? So that is A, right? Now here, mass number of one nucleon. Okay, so mass number, generally this is mass number of one nucleon. It is 1.66 into 10 to the power of minus 24 grams. So this is a general statement. So mass number of one nucleon, that is 1.66 into 10 to the power of 24 gram, right? Mass. Okay, now nucleons per atom. Okay, nucleons per atom. Nucleons per atom is equal to, that is mass of one atom divided by mass of one nucleon. Mass of one nucleon. Right. So that means what is the answer you will be getting? In the question, it has given no 3.32 into 10 to the power of minus 23 divided by what it is? 1.66 into 10 to the power of minus 24 gram, right? So this is a gram. So this is also gram. So this is given mass divided by molecular mass, like that. This is actually what it is, mass of one nucleon. That is what I have given. No, I hope you got that idea. So this gram and gram will be cancelled, and this is also here what it is, 23, here 24, no, so 1. So when it goes upward, so you will get what it is, you will get 20. Okay, so nucleons per atom. So nucleons per atom, it is 20 nucleons per atom. Got it? Okay, now each atom has 20 nucleons. Each nucleons, it is nothing, mass number only. So each atom, so this is per atom only, no, so each atom, so that means they are asking 2 atoms. So each atom has 20 nucleons. So that means mass number, it is 20. Just now I mentioned, no, so nucleons, it is nothing. Protons plus neutrons, so that is also known as mass number. It is symbol, it is A, that you know. Okay, atomic mass number. Okay, atomic mass number equal to what it is, 20. Right now, total protons. So total protons, it is actually what it is, total protons. So total protons, that is actually double that. Okay, so that means 20 into 2, it is 40. Neutrons only, it will be vary. Protons, it is constant. Protons, it is nothing. Atomic number, it is constant. Atomic number only gives the place 1, 2, 3, 4, 5, 6, like that. Okay, total number of proton, total number of neutrons. Okay, total number of neutrons. neutrons equal to what it is here also 10 into 2 20 because they mentioned what it is 20, so 2 into 20, so that is 40. So 2 atoms present in that, no, so it's common. So 2 atoms of element, 2 atoms of element, so that is 40. I hope you got that idea how to identify. I think a number of questions, if you practice, you will get that complete idea about that. Right now, these are all the points to be noted down when you are learning. Okay, now which is the correct option? Option 40. They did not mention anywhere Avogadro number, so nothing to worry about that Avogadro number. Number of what it is here, calculate number of nucleons, that is protons and neutrons present in 2 atoms of the element only they mentioned. They did not mention that complete atom. So when you coming in that way atoms, you can use Avogadro number, but here they did not mention in that. So here they mentioned what it is here, neutrons and the protons, nucleons only they mentioned. So here option yeah, A is the correct option. Right, got it? So A is the correct option. 40 is the correct option. Right, come on, let us go to the next question. The number of electrons present in 9.5 gram of phosphate minus 3. Okay, so PO4 3 minus ion they mentioned. So here generally calculate the number of electrons. Okay, how do we go for this to solve this sum? Okay, now here molar mass of phosphate ion, right? So molar mass of phosphate PO4 3 minus. So phosphorus, how much here? Phosphorus actually 31 plus oxygen 4 into 16 plus, so phosphate only. Now ion after that we will add because 3 minus means it's gaining charge now. Okay, so molar mass of PO4 only we can consider, then after that we can go for it. Okay, now here what it is, 95 gram per mole. Right. Okay, now number of moles we have to identify. So number of moles of PO4 3 minus. Okay, generally number of moles means given mass by molecular mass only. So given mass, it is given mass by molecular mass. So given mass 9.5 gram in the question it has given. Molecular mass just now we found it is 95 gram per mole. So how much you will be getting? 0.1 mole mandatory, right? Okay, in that charge we have to consider. Okay, in the charge what it is, in that charge PO4 3 minus. So PO4 3 minus, what it is, phosphorus, it is 15 electrons, right? Okay, now oxygen, it is what it is, oxygen how much? It is 8 into 4. So that means what it is, 8 into 4. So this is 4, no. So 8 into 4, what it is? Here 32 electron. I hope you understand. And charge, it is 3 minus. So minus 3, usually it is gaining of electrons, right? Losing of electrons means plus Mg2 plus Ca2 plus, that means 2 electrons it is contributing to complete that octet. Here gaining electrons means minus, so that means addition of electron. So this is plus 3 electron. So total number of electrons together. So total number of electrons together. So total electrons, how much here? 50 electrons. I hope you got that idea. PO4 3 minus, PO4 3 minus. So altogether, how many electrons are there? 50 electrons are there. Got it. Okay, now total number of electrons, 50 electrons. Now multiply with that what it is, number of moles by Avogadro number. So total number of electrons, total number of electrons equal to moles. That is number of moles, right? Moles into Avogadro number into number of electrons. Just now we found that number of electrons, and moles also we just now we found given mass by molecular mass, and Avogadro number you know very well. Right, now can we apply the value? 0.1 into Avogadro number, we just mentioned Na only, into here 50 electrons. So how much here? Can we write here 5 Na? What it is Na? Na it is nothing, Avogadro number. So directly instead of multiplying, we can put it directly, or else 5 into 6.023 into 10 to the power of 23 electrons, right? So you will get the answer how much? 3.011 into 10 to the power of minus 24 electrons. I hope you got that clear idea. This also it is correct, and when you're calculating these together, specifically this is the correct answer. Okay, come on, let us check what is the correct option. So here the option they have given, yeah, they did not multiply with that, just they have given the symbol way. So that means 5 Na is the correct option. I hope you got the clarity. How do we go for it? Just check it once again, pause the video and just check it so that you will get the complete idea. Come on, let us go to the next question. What is the number of moles of oxygen atom in 126 AMU of HNO3, nitric acid. Okay, this is also interesting only. Now here 1 AMU, here 126 AMU they mention. No? So 1 AMU, generally 1 AMU equal to how much? 1.66 into 10 to the power of minus 24 gram. That is nucleons we mentioned. No? The same. Now 1 mole equal to 6.023 into 10 to the power of 23. Right. Now molecular mass of HNO3. Molecular mass of HNO3. How much it is? Hydrogen 1, nitrogen it is 14, oxygen 16 into 3. All you have to add. So that means you will get what it is? 63 AMU, because they mentioned everything it is in AMU. No? So we mention in that way AMU. Gram per mole also you can mention. In the question it has given the answer AMU. So we can go in that way also. Right now, number of molecules. Number of molecules, that is 126 AMU, that is given mass like, and here molar mass, it is given mass by molecular mass. No, so here what it is? 63 AMU. Whichever way you just go, that is a fundamental concept only. Given mass by molecular mass or given AMU divided by molar AMU. That is the way you can. Now here the answer you will get what it is? 63 when you calculate this. Here 1, here 2. So you will get 2 AMU. Right, number of molecules, it is 2 AMU. Now, in the question, it has mentioned what it is. What is the number of moles of oxygen atom? So, number of molecules. So, how many oxygen atom is available? So, each molecule of what it is? Each molecule of HNO3. How many oxygen is available? 3 oxygen atoms. 3 oxygen atoms are available. Right, HNO3, how many oxygen atom? 3, right? Okay, now total number of oxygen atom in 2 molecules. So total, that is 6. Easily we can identify. So total number of oxygen atom. Total number of oxygen atom. So here how many molecule is available? So here 2 molecules. 2 molecules into 3 oxygen atom. Right now, what is the answer you will get? How many oxygen totally? So total number of oxygen, it is, you know very well, that is 6 oxygen atom. Okay, oxygen atoms. Right, now here, number of moles we have to identify. Here, number of moles of oxygen atom. Number of moles of oxygen atom. So number of moles of oxygen atom, that is number of oxygen atom, number of oxygen atom divided by Avogadro number. So number of oxygen atom, how much? It is 6 divided by Avogadro number. Avogadro number 6.023 into 10 to the power of 23, or we can put it Na. So this is the way we can identify. Okay, hope you got that idea. So number of moles of oxygen atom. Here the question they have asked about what it is? Number of moles of oxygen atom only they have asked. So number of moles of oxygen atom, it is 6 by Na. So option D is the correct option. Option D is the correct option. I hope you got the clarity. Come on, let's go to the next question. The next question, what is the charge of 96 AMU of S2 minus ion? See here, AMU only they mentioned like last question, right? Now atomic mass of sulfur. So here atomic mass of sulfur, that is what it is? 32 AMU. So sulfur, generally we say AMU right here. Okay, now here what it is? Ions, number of ions. So number of ions, how do we identify? That is given mass by molecular mass, also number of moles, here the number of ions. So here that given AMU, it is 96 AMU, and here atomic mass of AMU, it is 32. So this is also AMU, that is atomic mass unit. So you will get how many ions? 3 ions, right? So you will get 32, that is 3 ions you'll be getting. Right now, in that S2 minus ion, S2 minus. So how many ions are carries? Actually, it is 2 ions, right? So here actually 2 ions. 2 electrons also we can say. So total charge of ions. So here total charge of ions, how much here? Total charge of ions. How much here? That is 3 ions, no? So 3 ions into, now how many charge over here? That means electron. Here 2 electrons. So you will get how many together? Total number of electrons, it is 6 electrons. Okay, charge of electron, you have to identify the charge of electron. Now generally charge of electron, what is that number you will use? So charge of electron. It is 1.6 into 10 to the power of minus 19 coulomb, that you have known already, right? Avogadro number, 1 AMU equal to, then charge of electron, charge of proton, these and all you have to learn thoroughly. Right now, total charge of ions, right? So total charge in that coulomb, total charge in coulomb. So here what it is, 1.6 into 10 to the power of minus 19 coulomb into charge, how much? Here 6 electron, no. Number of electrons, it is 6 now. So altogether you will get 9.6 into 10 to the power of minus 19 coulomb. I hope you got the clarity. How do we go for this? Okay, this is very simple. Come on, what is the answer? Here 9.6 into 10 to the power of minus 19 coulomb. Option C is the correct option. I hope you got that idea. How do we go for it? Come on, let's go to the next question. A sample of sodium has a mass of 46 gram. What is the mass of the same number of calcium atoms as sodium atoms present in the given sample? Right. Now they are asking about that actually. Same number of calcium atoms as sodium atoms present in that. Okay, to find that calcium atom, we have to find that number of moles of sodium atom. So number of moles of sodium atom. Number of moles of sodium atom, how much? Given mass by molecular mass, no, the same number of moles, given mass by molecular mass. So given mass here, what it is, 46 gram, no, molecular mass, what it is, 23, right? So given mass, it is 46 gram, and molecular mass, sodium, what is that atomic number? It is 23 gram per mole, right? So here 23 gram per mole, right? So you will get gram cancel, so you will get what it is, 2, right? So 2 moles. Now generally, this point you might have known very well. According to that Avogadro's principle, equal number of moles contain the same number of atoms. So actually, equal number of moles, that is equal to number of atoms. Equal number of moles contain same number of atoms. Same number of atoms. So that is Avogadro's principle. So we need 2 moles of calcium. So 2 moles, as they are mentioning now, calcium and sodium both are same as equal, they mention now. So we need 2 moles of calcium atom. So moles, if we find, it will be easy for us to find out that mass, atomic mass of calcium, right? Atomic mass of calcium, atomic mass of calcium, how much? 40 gram per mole. Right, now formula mass how much? Formula mass equal to moles into molecular mass. Molecular mass or atomic mass? Atomic mass, anything. So moles into atomic mass or moles into molecular mass. Okay, calcium only they mention. So here 2. So this is moles, it is equal, right? So moles into atomic mass. Atomic mass of calcium, it is 40, right? Gram per mole. Right, so now you will get what it is. This is mole. This is also mole, right? So mole cancel. So how much it is? 80 gram. So what is the question it has mentioned? Here 46 sodium atom has, I just mentioned, sodium atom has 46 gram. What is the mass of the same number of calcium atom as sodium atoms present in the given sample? It is 80 gram. So it is actually what it is, 80 gram of that atoms. Okay, calcium atoms as sodium atoms present in the given sample, it is 80 gram. So calcium atom as 80 gram, right? I hope you got the clarity. So sodium atom has 46 gram means calcium atom has 80 gram. I hope you got that idea. Come on, let's go to the next question. In total number of neutrons present in 54 ml of water in liter, they're asking. Okay. Actually, mass of water. Let us go and identify that mass of water. So mass of water, it is another name, density of water. Okay. Okay. Now mass of water. Mass of water, we can write it H2O only, or density of water. Density of water. So here density of water, mass of water, generally 1 gram per ml, right? Okay, density of water. So density of water, it is actually what it is when we go for that mass of water, M equal to V into D. So V into D, density equal to mass by volume, right? Mass equal to volume into density. So volume into density here, what they mentioned, 54 ml. Right, mass of water. So it is volume into density. Volume, it is 54 ml into what it is, density, it is 1 gram per ml, right? So you will get what it is, ml will be cancelled, right? So you will get 54 gram. So mass of water, it is 54 gram, right? Mass of water, it is 54 gram. Molar mass of water, right? Mass of water It is 54 gram. And the molar mass of water, molar mass of water, right? How much here it is? That is water, H2O. So it is 18 gram per mole. Molar mass, no, 18 gram per mole. So number of moles, it is easy. Given mass by molecular mass. Given mass, it is what it is? 54 gram, right? So number of moles equal to mass by molar mass equal to 54 gram by what it is? 18 gram per mole, right? So gram will be cancelled. So 54 divided by, so that is 3 moles, right? So number of moles of water, it is 3 moles. Right, number of moles of water I just mentioned here. So number of moles of water, 3 moles. Right, number of molecules. Here they mentioned, number of molecules. Number of molecules. Moles into, that is moles. Moles into Avogadro number. So moles, how much? Here 3 moles into Avogadro number 6.023 into 10 to the power of 23. Right, so you will get, when you calculate, you will get, generally in the option they have given 3 Na only they have given. Okay, I hope you got the clarity, right? So number of molecules, it is 3 Na. Yes, got it? Which is the correct option? So number of neutrons present in 54 ml of water. So that is 3 Na. It is so simple, right? It is very simple. All right, come on, let's go to the next question. I hope you got the clarity. Yes. Total number of electrons present in 48 gram of Mg2 plus. Okay, now here number of moles, let us identify. So number of moles of magnesium ion. Okay, so number of moles of magnesium ion, it is given mass by molecular mass. No, so given mass, it is 48 gram. Molecular atomic mass of magnesium, it is actually 24. Okay, so number of moles of magnesium Mg2 plus. So that is given mass by molecular mass. No, so that is 48 gram divided by 24 gram per mole. Right. So you will get what it is? You will get 2 moles. 2 moles. Okay, electron per magnesium ion. Okay, now here Mg2 plus ion they mention. No, so electron per magnesium 2 plus ion. See, here actually minus charge means your addition of electron. Plus charge means it is donation of electron. So that means atomic number of magnesium, it is actually atomic number of magnesium Mg, that is actually 12 gram per mole. Right. So that means 12 electron. So 12 means atomic number means electron plus electron equal to proton, right? So that means 12 electron or 12 proton. So 12 electron, and it is what it is here, plus or minus. So here actually what it is, 2 electron, it is donated. No, so that means here minus 2 electrons. So that means how many electrons you will get here? 10 electrons only. So that means number of electrons in Mg2 plus. So 10 electrons only. Right here, number of ions and the number of electrons. Total number of ions and total number of electrons we have to identify. So total number of ions. Total number of ions, how much? Here, moles into Avogadro number. Moles into Avogadro number. Moles into Avogadro number. Moles, how much we have found? Here, moles. Given mass by molecular mass, 2 moles we have found, right? So here, 2 into Avogadro number, Na. So that is total number of ions. Now, total number of electrons we have to identify. So, total number of electrons. So, total number of electrons, here what it is? Total number of ions into number of electrons. Okay, number of electrons per ion no, Mg2 plus. Okay, now here total ions into electron per ion. Right, so that means here 2 Na, right? This is 2 Na, right? So total ions, it is 2 Na, 2 Avogadro number, into how many electrons, total number of electrons per ion, that is 10 electrons, no? 10 electrons. So altogether it is 20. It is 20 Na. 20 Na also you can write, or else 20 into 6.023 into 10 to the power of 23. That way also you can write it. So what it is? Total number of electrons. This is total number of electrons. Right. So total number of electrons it is. I just calculated. Total number of electron is 1 point. I just here 1.204. Okay, 204 into 10 to the power of minus 20. Here 20, 23, 25. 25. 1.20 4 into 10 to the power of 25 electrons. Okay, when we calculate now this 20, so 2 digits extra. Okay, I hope you got the clarity now. Which is the correct option? Come on, let us check. 20 into Avogadro number. Okay, 20 into Avogadro number. Yes, option C as the correct option. I hope you got the clarity. Come on, let us go to the next question. Here only the next question is here. Yes, now here for that, which is the correct option? Option C is the correct option. Okay, the next question is number of neutrons in 5 grams of D2O. And D2O, it is a hydrogen isotope, no? Hydrogen, protium, deuterium, tritium. So 1H1, 1H2, 1H3, 1H1, 1H2, 1H3. So that means deuterium, it is 1H2. So which does not have neutron means protium does not have neutron, right? So hydrogen isotope, protium does not have neutron. So because of neutrons only, it is varying. So isotopes are formed, right? Okay. So number of neutrons in 5 grams of D2O, that is heavy water. Okay, come on, let us go for it. So atomic mass of deuterium, right? No, this only, deuterium D, right? Deuterium, right? Okay, now atomic mass of deuterium, atomic mass is this only, right? Atomic mass of deuterium. I just mentioned D only. D, it is nothing. Deuterium, that is 2, right? 2.014 gram per mole. That is actually 2 commonly we can mention. Okay, oxygen atomic mass. Oxygen atomic mass. How much it is? 16 gram per mole. Right? Okay, now the next point. Total D2O mass, molecular mass, right? Total D2O, H2O like D2O, heavy water. So it is 20 gram per mole. H2O, no, so it is 2,4, no, so 20. Right, now neutrons per mole. Neutrons only they are asking, neutrons per mole. So because of neutrons only, it is varying that. Okay, now here each deuterium has 1 neutron. Each deuterium has 1 neutron. So that means here atomic mass, what it is here, A minus Z, no, to find out. Okay, A minus Z here, mass number minus atomic number. So you will get 2 minus 1. So you will get 1 neutron. Okay, so here N means mono nitrogen like, no, that is what purposely I mentioned. Okay, now here 2 deuteriums are there. D2O, no, here 2 deuteriums are there. So 2 deuteriums atoms contribute how many neutrons? 2 neutrons, right? Okay, that means oxygen, how many oxygen? Oxygen 8, oxygen 16, right? So 8, oxygen 16 means here 16 minus 8. So how many neutrons will be available? 8 neutrons. So altogether, total neutrons, it is 10 neutrons. Right, got it. Okay, now it is moles of D2O we have to identify. So moles of D2O, what it is? Moles of heavy water, D2O. So moles of D2O, given mass by molecular mass, So D2O, it is 5 grams divided by 20 gram per mole. Right, so you will get what it is? 0.25 moles you will be getting. Right, so moles of D2O, you got it. Right, now total neutrons, it is total neutrons equal to moles into neutrons. Right, so moles, how much it is? 0.25, no? So 0.25 moles into 10 neutrons. Right, so here what you will get it here? 2.5. So the total neutrons, it is 2.5. So here actually multiply with Na also. Na, it is nothing, Avogadro number. So total neutrons when we consider, we have to multiply with that Avogadro number also. So that means here Na, right? So 2.5 Na, right? So 2.5 Na, that means here what is the answer? So you will get 2.5 into 6.023 into 10 to the power of 23. So you will get 1.5055 into 10 to the power of 24. So total number of neutrons, it is this one, right? Otherwise 2.5 Na. So which is the correct option? Right? 2.5 Na. So which is the correct option? Option B is the correct option. I hope you got the clarity. So B is the correct option. Come on, let's go to the next question. Cisplatin, an anti-canceral drug, has the molecular formula PTNH3 twice Cl2. What is the mass in gram of one molecule? So atomic mass of platinum 195 gram per mole, hydrogen 1 gram per mole, nitrogen 14 gram per mole, and chlorine 35.5 gram per mole. So here they have given all that. It is very simple, and this is an anti-canceral drug. Cisplatin, it is an anti-canceral drug. Okay, so total molar mass. Okay, total molar mass of cisplatin. So what is it, cisplatin? Okay, PT, that is platinum, NH3 twice Cl2. So here this is platinum. They have given everything. They have given that mass number, atomic mass. Okay, 95 and 1 and 14 and 35.5. So here this is actually 195 plus nitrogen 14. What it is? Ammonia. Actually, ammonia, it is 17 into 2. So 17 into 2, 17 into 2 plus, and here what it is? 35.5 into 2. Cl2, no. So altogether, you will be getting around 300.06 gram per mole, right? Gram per mole. Right now, here what it is? Mass of one molecule. So mass of one molecule. Mass of one molecule, that is molar mass. This is very simple. Molar mass divided by Avogadro number. So mass of one molecule means this is molar mass by Avogadro number. So you just apply the value here. 300.06 gram per mole divided by Avogadro number 6.023 into 10 to the power of 23. Right? Molecules. Molecule. Right? Molecule per mole. Right? Now, here the answer when you calculate mass of one molecule. Mass of one molecule. One molecule, when you calculate this, you will get 4.98 into 10 to the power of minus 22 grams. Option, let us check here. Here, 4.98 into 10 to the power of minus 22 grams. Molecule, one molecule. That is, what is the mass of one molecule of this anti-canceral drug medicine? One molecule. So, which is the correct option? Option B is the correct option. 4.98 into 10 to the power of minus 22. I hope you got the clarity. So generally they will ask such kind of questions. I hope you understand all these questions, and thank you for watching the next question in our next video, and till then, thank you.